So number 15, we're going to use a substitution for this. And we're going to use a unique substitution in that when we take a look at the inside function here, I'm going to let u equal x minus 1. Now, the reason I'm doing this is because this binomial in the root is actually a problem. If the binomial was actually out of the root and into the powers, we could actually isolate powers on these x's. So when I do the substitution, I'm going to just rearrange this and make x equal to u plus 1. And because u and x are just proportional linear relations to each other, du changes proportionally with dx. Okay, so when I differentiate that equation, I get du equals dx. So what happens then? So when we plug this in, when I do my substitution, I'm going to end up with something that looks like this. So I'm going to end up with 3x cubed minus 2x squared. But that x cubed and x squared, really I'm going to replace with u plus 1 and u plus 1. And then the square root, I replace with just a u. And then because du and dx are exactly the same, I just replace the dx with a du. And now I have a polynomial which I can isolate powers on in terms of u with a du. So then when I expand this all out, I end up with u cubed plus 3u squared plus 3u plus 1 minus 2 times u squared plus 2u plus 1, and that's all going to be multiplied by, and I'm going to maybe make that u to the power 1/2. And then times du. Okay, combining like terms, I'm going to end up with 3u cubed. I end up with 9u squared minus 2u squared. So that's going to give me plus 7u squared. When I multiply this out, I get 3u minus 4u. So that's going to be plus, so 3 times 3 is 9u minus 2 times 2 is 4u. So I end up with plus 5u. And then I end up with plus 3 minus 2, so plus 1. And that's all going to be u to the 1/2 du. And then I can finally get my powers here. U to the power of, this becomes 7 over 2 plus 7u to the 5 over 2 plus 5u to the 3 over 2 plus u to the 1/2 du. And then at this point I can anti-differentiate this. So I end up with u to the power of, I'm going to increase the power by 1, so 9 over 2, 3, and then I end up with 2 divided by 9 as my coefficient. Okay, so divide by 9 over 2, so that becomes 2 over 9 in the 2 in the numerator, 9 in the denominator. Plus, this becomes u to the power 7 over 2. So this becomes 7, 2 on the top, and then I had my original 7 there. Okay, so those 7s are going to cancel out. Plus, this becomes u to the 5 over 2. That 5 over 2 becomes divide by 5 times by 2. Plus u to the 3 over 2, and that becomes 2 over 3, and then I have my plus c. Okay, so simplifying this out, I cancel some common factors here. That becomes 3, those cancel out, those cancel out. And so I'm left with 2 over 3 u to the 9 over 2 plus 2 u to the 7 over 2 plus 2 u to the 5 over 2. Okay, I'm just going to make a little bit more room here. Plus 2/3 u to the 3 over 2 plus c. Okay, and then I back substitute my substitution of u is equal to x minus 1. So then my answer is going to have this same thing, but x minus 1 inside these brackets. Okay, and then that gives me my final antiderivative.